Hello and welcome to this video. In this video I will show you how I've used artificial intelligence to connect to a couple of Azure SQL databases to bring back data from questions that I will ask it. I have not created any stored procedures or views in these Azure SQL databases. The large language model will try to work out the answers that I require from the inputs that I will give it. So without further ado, let's continue with this video. So for this example, I'm using Microsoft Foundry to connect to a couple of Azure SQL databases, and those databases are Northwind and AdventureWorks. So I'll just show you both of them really quickly. So here we are. So in the AdventureWorks schema, you've got all of these tables, and if you look in the Northwind schema, you can see all these tables. You can see that they're using different schemas and they're using different tables in both databases. There are some common table names like products, and there's product in here, and there's products, and there is also, but there's actually a customer and customers table. So if you look at the customer table in AdventureWorks, it's got this it's got these details with these column names, and if you look at the customers table in the Northwind database, it's got this format for table information. So what I want really is for the AI large language model to understand when I want to bring back customer information. I want it from either of one of these two tables. So I'll just move this out of the way. So for my first test, I will just keep it simple, and I will ask it a question. And from here, it's going to assume some of what I want from their response. So assume that I want information from the Northwind database, and this is how it's calculated the total sales, and it's looked at the query, and it's just saying it's safe to run, but it's relying on some assumptions. What the large language model has used, and this is the query that is going to run against the database. So as you can see, it's going to connect to the Northwind orders table with some joins, and it's just generated a SQL query. And it's good that it's generated a SQL query so you can see all the information or all the statements it's going to run against your database system. So you've got a bit more trust in the code to say, yes, I'm happy with this SQL, you can run it. So when I press run query, it'll run against the Northwind database, and it will bring back this result. So as you can see from here, it's just given a bit of a summary of what this information is, and it says the result shows up Margaret and Peacock is the top salesperson, and as you can see that person is. So I didn't tell it to do that explanation, it's just done it itself. I mean, I have coded it to say output what you think this data means, but I've not actually written this in any database system or anything. It's understood the data and it's come out with that conclusion. For my second test, I'm going to pick information from the customers table, and as I shown before, there is a customer and customers table for it to pick from. So I will first prompt it a simple question, and this was to show the top 10 customers by total sales amount. And because I've not really been very specific, it's given me this tip to say, look, can you be a bit more, can you shorten down the time range, or just tell me a little bit more about what you really want to do? So what I will do, I'll give it a better time range. Between 2020 and 2026, and I'll run that, and it's saying, look, I can see there was two different customer tables. Is it an AdventureWorks one or it's a Northwind one? So in this example, I'll pick the AdventureWorks and submit for clarification. And it will again assume certain things about the data in the database, and it will generate a SQL query. As you can see, it's going to go against the AdventureWorks database, and again it will run this query. If I press the run button, and it will generate the result, and you can see that Terry is the top earner, and it's got this amount of money, and it's actually written an explanation, an insight of that data as well, with Tony and being there with this amount. And it even says followed by these people, by this person. If I was to run this query again, again it will come up with the options AdventureWorks Northwind. So this time I will pick Northwind and submit this one, and it'll done assumptions, and this time it's assuming the customers from the Northwind one, and it's written a different type of query, and this time it's going against the Northwind database. And if I press run, it's bringing back this data from this table, and it's saying quick stop is the top sales in this result set. I have not written any stored procedures or views or anything. It's just a large language model understanding the data and bringing back the information that it thinks I want. And if you're not too sure, you can look at the assumptions just to make sure that is exactly what you are asking. And if you are good at SQL, you can read the SQL statement here. You can copy and paste it into your own database systems and run it as well. And here there's another tab in how the query works, and it's giving a little bit of an explanation of how it works and how it came to that answer as well. So it gives you all the information of how it generated that result. On the screen, I'll just move it to the side a bit so you can see it a bit better. Yep, there we go. So you can see the results here. It's saying, yeah, that's the top person, and you can see all the results there. And also, you can press the download button, and if you press the download, it makes a download. And if I open this up, it will open up in Excel, and you can play around with the results in Excel. So I'll just do a couple of more tests now. So I'll give it another question, and I will say give me the top 3 customers from 2000 to 2026, and show the total sales amount in UK pounds. So if I press run, again it will say which database, so I'll just pick AdventureWorks, and this time it's generated a query. It's changed the output column name, and if I run the query, as you can see, the output has changed. But what happens if I want to actually put in the monetary symbol, like the pound sign itself? You can actually do that as well. So if I was just to change the prompt and change the prompt to something like this, and say, and put the pound symbol for any currency inside the query, and I press run, I pick Adventure Works. It'll run the query, and you can see from the SQL code it's putting the pound sign in. And if I run this, as you can see, it's changing it into monetary values. So I'll go back to Excel. So that is a very quick demo of this AI data assistant using Microsoft Foundry and using Python and using Azure SQL databases. In future videos, I might try and improve the front end a bit, ask it more complicated questions, just to see how far you can push the large language model into doing things and understanding your data without spending hours and hours of time writing complex code or complex stored procedures. And from all of the experimentations I have done with this, you just have to make sure that your data is of high quality and all your data models are functioning correctly, because it just makes the large language model search your data faster and quicker and understand it better if everything is actually okay in the back end. So that's the end of this demo. I hope you've enjoyed it. I hope it's inspired you to go out and start using AI to interact with your data. And I hope you've enjoyed it, and thank you and goodbye.